Today we're going to be talking about series and something called summation notation. Now, we've been talking about sequences for a while now, and when you add a sequence together, it is called a series. So if you want to think about it as a sequence is just a list of numbers, a series is when you add those numbers all together. And we have two types of series, just like how we had two types of sequences, or we had more than two types of sequences, but we had finite sequences and infinite sequences. We have finite series and infinite series. And again, these three dots mean that it's infinite. You can use what's called summation notation. Summation notation, also called sigma notation. And what sigma is, it's basically think of it as a sideways M. This symbol down here, that is the capital letter sigma, and that's how we notate that we are taking the sum. So look at these series up here and notice that we have our explicit rules. We use our explicit rules. And we have 2 plus 4 plus 6 plus 8. And we'll zoom in really close here. And what this means is that where our variable is I, and we're going to start plugging in 1 for I, and we're going to stop once we get to 4. That's why you only see 4 terms right here. 1, 2, 3, 4. We start by plugging in 1 for our explicit formula here, and then we keep going and plugging in 2 for I, 3 for I, until we get to this upper limit here, and then we're done, and then we can add up these values, and that would be the summation. Over here, same idea, except these 3 dots means that this goes on forever. So that upper limit has an infinity symbol there, meaning we keep going, which means we can't actually get a sum. Like, we can't simplify this and say, oh, this sum is going to equal to 20, like we could back here. We add all those numbers up and we get 20. So to kind of summarize, in both series, the index of summation, or the variable, is I. I equals 1. I equals 1. The lower limit of the summation is 1. That's where we're starting. And for the finite series, the upper limit was at 4 that I circled. And for the infinite one, it was infinity for that infinite one. And like I was saying, summation notation is also called sigma notation because it uses that Greek letter sigma. All right, so down here we're going to write these series using sigma notation. So first we're going to have to identify, is it arithmetic, geometric, or neither, and write the explicit rule for that term. So what we did over the past couple of days on how to write explicit rules, we have to do that, and then we have to determine if it's infinite or a finite sum, and find the position of that last term, like how high do we go. If we look at example 1, letter A, if we look at this, we're adding 3, 1, 2, 3, position, and we don't know what this position is at the very end, but we're adding, we are adding 3 each time. So my difference is, or my D value is 3, and that point that we're using is 1, 4. And again, we could go and use this formula A sub n equals n d times n plus b, and plug in 1 for n, 4 for a sub n, like this. We can do this process, but one of the things that we came up with is, why can't we just go backwards one, because we're given a 1. We want like the 0 term, but you are able to do and say, oh, b is going to be 1. Right? If my b value is 1, my explicit formula is going to be 3, well, let me write it this way, a sub n equals 3 times n plus 1. Well, we have to figure out what n value gives us 46, because that's going to tell us our upper limit of summation. So we know that a sub n is 46. We know that 3n, we don't know what n is, but we have that plus 1. Subtract 1, 45 equals 3n. Divide both sides by 3, and we're going to get 15 equals n. So this is the 15th term right here. So now we can write our summation notation. So n is equal to 1. That's what we're starting. And our formula was 3n plus 1. And our upper limit is this 15 that we calculated. So that would be our summation notation. Over here, first thing I notice is that we have these 3 dots, which means this is an infinite series. And I'm looking at my denominators here, first term, second term, third term, fourth term. And these denominators are all perfect cubes. 1 cubed, 2 cubed, 3 cubed, 4 cubed. So this one isn't going to be too difficult at all. 1 over n to the third power, where n is starting at 1. And because we have those 3 dots, we're going all the way up to infinity. And that would be our final answer. This one, we're adding 7 each time. You can see that plus 7, and so on. And some of you might say, well, can't I just keep adding 7 and see how many times that takes me to get to 77? You could do that, but it's very easy to miscount how many times you added 7. And what if we're going up to like 30? That's going to take you a long time. So our difference is 7, and the point that we can use is 1 comma 7, that first term, and then 7 equals 7 times 1 plus b. Again, we're plugging in those points into this formula right here. And we're going to get that b is equal to 0, which makes my explicit formula 7 times n. And you could use whatever letter variable you want. Some books use I, some books use K's. It doesn't really matter as long as you're consistent. So now we need to figure out 77 equals 7 times n plus 0. Well, n has got to be 11. So 11 is equal to n. So we're starting at n equals 1 and going all the way up to 11. And that would be your summation notation. All right, now with this one, these three dots mean again it's going to be infinite. So if you want to, you can just put the infinity symbol on top. And as we're going through this, you'll notice that we're multiplying by 2 each time. So this is going to be geometric. Well, since it's geometric, we know that formula, a sub n is equal to a1, the first term, times r to the n minus 1 power. So our a sub 1, my first term is -4, so I'm going to have -4 times my rate, which is 2 raised to the n minus 1 power. And that would be our final summation notation. Oh, whoops, I forgot one last thing. N is equal to 1, the bottom limit, the lower limit. Now on the next page, we are actually going to evaluate or find the sum of this series. And these are probably more time consuming than anything, because now we have to just plug in values. Notice, that the lower limit here is 3, not 1. So what we're going to do is we're going to plug in 3 and get a value. 2 minus 9 is -7. Then we're going to plug in 4. And that's going to be, oops, it's -3. Okay. So that is going to give us -10. And then the last one is going to be 2 times 3 and plugging in 5. And that's going to give us -13. And then we need to add all of these together. -7 plus -10 plus -13. So this summation is equal to -30. So what I want you guys to do is I want you to look at these two and complete them. Pause the video and look at it and try them. Again, it's really not that difficult. It's more time consuming. You're plugging in this lower limit in for k and then working your way up to the upper limit and then adding all of that together. So pause the video. Once you're done, unpause it to check your work against mine. All right, so here are the answers and how I got them. So go ahead, check. Hopefully you got the same thing, and if not, you can see the work that I did and fix some mistakes that you made. So thanks for watching the video. Make sure to like this and subscribe.